Welcome to Red Door Family Farm. I'm Tenzin Botsford. My wife Stacey and I own and operate the farm. We've been here about 12 years, and we grow about 10 acres of mixed vegetables, organic vegetables for sale through CSA, farmers market, increasingly more wholesale and bulk deliveries to food banks, and some hunger relief work that has been great and really rewarding. We have a short growing season here, and so we just kind of try to have as much diversity as we can, as much of the season as we can, without pushing into like heated tunnels and stuff like that. We do have 6 high tunnels as well as 1 heated like propagation greenhouse. The high tunnels are unheated, growing in the ground. And we farm kind of extensively, so we don't, aside from the tunnels, we don't really double crop anything. But what we do is we get a vegetable crop and a cover crop. So there's either a spring cover crop and a vegetable crop, or a fall, I don't know, whatever. So on pretty much every field gets a crop and a cover crop every year, except we have 6 fields in rotation, and one of them has a full year of just cover crop soil building, and we'll look at some of that in a little bit. I don't know how far back to go here, but this all just kind of started because we didn't know what we were doing, and we just sort of felt like if we just show up and stop using poisonous chemicals, the ground will be just so glad that we did that it'll bring forth food, and that didn't work very well. So then we started buying a lot of poultry manure, composted poultry manure, and that worked better. But it still was kind of a mess and didn't, I don't know, we'd get it all in one truckload, usually on a wet day in early spring, and try to spread it out, and it just didn't really go well either, but at least things would grow, especially weeds started growing then. So then we decided to get a little bit more sophisticated about it. We had an agronomist who just kind of showed up in the yard and started working with us and taking some soil tests and showing us how to do that, and that was really helpful, but then he retired like a year later. So I just started reading and getting interested in it, and then once I did, I couldn't stop. And so I've gone through a lot of different iterations, and I think, in all cases, it's an interesting scale to be at, where we are generating our income off of the farm. We've got about 5 very dedicated, great, hardworking employees, and us, and then many other like kids' friend type employees. And so it's an interesting scale to be at, because what we're doing, we can really afford to put a fair amount of money toward an acre. That's a very high return on a per acre basis compared to corn and soybeans or most other forms of farming. But there's enough acres and enough ground that the bigger limiting factor is time and energy and equipment and that sort of stuff. So as I've kind of been learning different things about soil health and implementing different strategies, a lot of it has been based on trying to figure out what is the best option, and then trying to figure out like what's a entry point that I can actually hit. So I'm a lot more ambitious in January than I am in July, for example. And so I think that's kind of the scope of what we're doing here. If anybody has questions about that, we can do that while we're in here. Otherwise, I think we'll just head out to the field and start looking at some different practices that we do.
How much do you think your land has improved since you took on that new
system? That's an interesting question. So when we started, I didn't even know what I was looking at. So it's a little bit hard to know how much I've changed versus how much the ground has changed. But this year, we opened up some new ground. So we had an interesting just sort of natural experiment there. And that new ground, we had some that had Napa cabbage on it last fall, and then we had some where one of our employees grows flax for linen. And same variety, same planting, everything treated the same, and just right where that, because we extended the fields is what we did. So the same bed was going across the whole field, and we were at about half of the resolution of the part that we had been farming. So to me, that was very telling, and that had been fallow. It got a cover crop 12 years ago, and then it got mowed once a year since then, was basically the treatment. And I think that is a really interesting tell, because we were making no money off of that ground. We weren't putting any money into it either, but I would have thought that just letting things grow and do their thing would have really improved that soil structure and biology. And I didn't take measurements, but it was certainly harder to work up and less productive than the stuff that we had been actively farming. And I think one of the big, if I have a message that I want people to understand, if I'm selling any ideas, it's this. It's that we can farm the soil better rather, it doesn't have to be that farming necessarily degrades the ground. So we can make a profit, make sustainable businesses, and also be improving the resource year after year. And that kind of brings up another interesting thing, which is where this started. I was working with Rue a lot on these reduced tillage things, and I kind of balked when they asked about doing a field day up here, because I'm not very good at reducing tillage. I have done no-till experiments. I've not had success with them. And so really my focus has been getting better at tillage, doing a lot of things to offset the potential harms of tillage. But with vegetables, they are a pioneer. They're like whatever they've been bred to be, but they come from pioneer species of plants. So they would exist in a natural ecosystem after a disturbance. They would come up right away. And then more competitive things that are maybe slower to establish, but annual vegetables are a disturbance crop. And so I think that some of that stuff just doesn't suit very well. I know that there's a lot of people having success with deep compost mulch and stuff like that. And I did do a trial of that, and I didn't have very good success. But again, it's a short season. We're very busy. The things that are working have to happen first, and then trials happen where they fit in. So I'm not here to say that it doesn't work here. I'm just here to say that I didn't make it work. And yeah, so I think that we do a lot of things to really build soil health in spite of the fact that I do a lot of tilling. Kind of an example of our, plastic culture beds and our open beds that was close to the middle of the ground. So this is we call this our living aisle system, and we do this almost everywhere that we do these plastic mulched beds. The living aisle ways we do for a number of reasons. One is when it rains, these plastic beds, most of that water washes off, and so it'll just gully out and make a big muddy mess, and it takes days before we can drive back in here, and it's just kind of forever problems. So by having these living aisleways there, there's growing plants there to soak that water up. It also makes it really nice if we're going out to harvest. You're walking on almost a lawn, instead of just, sloped mud. And the other thing is that, these, there's not a whole lot of roots in the ground. If you just have the plastic mulch, there's not a lot of diversity in that field, and there's not a lot of different roots in the ground. So by doing, and it all kind of comes out at once. So from a soil microbes standpoint, I don't want to take a whole big block and give them nothing to chew on. So like if we mow that off and then pull that plastic, now there's going to be weeks before, even if we get right on it and plant another cover crop in there right away, it's still going to be a long time without much residue for them to work with. So what I like about this is now you've got a lot of diversity, and I've been playing with what goes in that aisle mix a lot. The main things that hold up really well, I use oats and millet, just so there's some sort of fast growing grass. If it's hot and dry, the millet will do well, and if it's cold and wet, the oats will do well. And usually white Dutch clover, except in our strawberries, because of thrips, not because of other reasons. But then I play with lots of other stuff in there too, just to kind of see what'll work. The white Dutch clover, and then in certain fields I'll use like an Italian rye or an annual ryegrass, and those really persist. So by the end of the season, now we've driven in here a bunch of times, we drive over it and mow this stuff off, we'll drive over it and pull the plastic out, sometimes we drive over for harvest. Even after all of that, then I can disc this thing up and plant cover crops, and in the spring we'll just get these ribbons of white Dutch clover and Italian ryegrass that come up. So that tells me that those roots stayed there. They were farming their own microbes, they were pumping sugars into the ground, so we've got this continuity that goes through. It does lead to increased tillage whenever it comes time to get rid of those aisles, because they're persistent. And what else do I want to say about that? In order to make them, we have a raised bed mulch laying contraption that makes the beds. It does a really nice job. And then I just drive outside the wheel track. So instead of driving in the same wheel track, I drive outside the wheel track, and that gives us that space there. Instead of putting them one wheel track apart, they're two wheel tracks apart. Like I said, we've got the space here, so we can do that. We're getting a little bit of the benefit of that cover crop in that growing season. And but then what it does is when we're done making these beds, now there's like a hard packed ridge where we just like drove, one wheel track here, one wheel track here. So you just got this hard ridge down the middle that's kind of a mess. And so what I did was I rigged up that tractor, which we can go look at here in a second. And what it does is it comes by and just makes sure that the edges, it's got some spider hose on the belly that makes sure that the edges of the plastic are covered really nicely. And what I want to do is just get a lot of soil up on there and get it nice and even to hold that plastic down. The discs on the bed shaper do that, but they just don't, it's not nice and even. And if it's not even, then I'm not going to be able to cultivate it well after that. So the more even it is, then the more effective that cultivation can be without having to be so aggressive that now I'm exposing the plastic edges. And then I put these rolling baskets on the back, and so when I go right after we make the beds, I do that to give that edge and then to erase that hard ridge and make sort of a seed bed in there. And then I just have a little Scott's lawn cedar push thing, and I mix up my cover crop seed. One other bonus is that's opportunity to put an inoculant. So I put an inoculant on that seed, and then that goes out there. And now this whole, so now I'm just making up completely inaccurate numbers, but if I put 100 units of inoculant on there, now the ones that do well in this environment have a whole bunch of different roots to choose from, and they're going to multiply out to 100 or 1,000 throughout the growing season. So we're like magnifying that impact through these aisles and keeping it in here during our growing season. And then I try to get them just right so that we've got a flail mower on a 2-wheeled tractor, and then we can walk through there and ideally get that magic spot between what the tractor cultivates on the edge and get the whole aisle without running into plants, but it doesn't always work. So this is the tractor setup that we use to make those living aisles. So after we use the bed shaper and lay the bed, I'll come along, these spider hose here, I'll have them set both the same direction in that case, and they'll just pull soil up and make sure that the bed edges are covered nicely so they don't fly away in the wind, and so that there's a even surface to cultivate later, and just plenty of it there so we can kind of cut it away each time we cultivate. These are just some track scratchers that help to take whatever loose stuff is there and kind of kick them toward the bed. And then these rolling baskets are what really takes that hard ridge I was talking about down and loosens everything up. So behind this tractor, there's kind of a looser seed bed for us to put out the cover crop seed. And again, I just use a simple little 30-inch push spreader for that. I do the small seeds, I keep in a little mason jar with some holes in the lid, and I just sprinkle them in as I go, because they work their way down through. So yeah, and then after that, then I just set these off in the weeds and I just cultivate with these, and then the open beds we cultivate with these and the scratcher there, kind of working in tandem to get that whole aisle. So this is an example of our compost when it comes here. So this is just bedded pack from some young stock at a dairy farm. And then what I do is I will mix that with ferment that we make. It's basically EM1, but I brew it up myself. And then, so I'll soak that in there. I will mix our micronutrient packs in there. Some of that, sometimes I do that with liquid, or sometimes I just toss it in there dry. Sulfur I'll put in there to try to hold on to more of the nitrogen in here. And this is a sawdust base, so it's got plenty of carbon. And then the farm that I get it from, they've got a big wheel loader, so they'll turn it for me, and they just send me the temperatures and turn it 5 times before it comes here. So by then it's reduced down to half the size, plus it takes them way less time because of their equipment. And they've got a good spot for it. And so then it comes here, and that serves as, or 4 times they'll do it, then it comes here and that serves as the 5th turn. And then here I let it mature for a full year. So right about there, this is gonna be next year's. We'll go out a year and a few months from now, and then the rest of this back will go out this fall, basically somewhat evenly on all the fields.
You're just putting out with a manure spreader?
Yeah, actually I've been borrowing the neighbor's manure spreader, but I think I did some rough math and I could have bought it about 4 times for the amount of fixes I've done. So I just bought that chopper box, and I'm hoping that not only that, it'll work better, but I can just put a lot more in there at a time, because it's I only get about 2 or 3 beds, and then I got to come back and refill, and it takes days. So this is our Johnson Sioux style compost. So this is what I use for an extract, and this that's the one we've been scooping out of. So that one's older. and then these are ready to go. And you were asking about what I plant into them, or you were asking about what I plant into the compost. So these two are our cover crop mix, and then this is just a vegetable seed mix and some buckwheat and other stuff. So for that same thing that you were, I think, getting to there, which is having the microbes that are associated with the types of crops that are going to be going out there. And I've been hesitant because I don't want to transfer disease that way either, but so far I haven't seen a lot. I mean, there's definitely like some issues, but I'm trying to grow a jungle in a pot, so I don't think it's necessarily disease issues. With the micronutrients, I had read somewhere that you can put like way too much into one of these things, and then when it goes out there, it'll actually, as an extract, it'll still make a meaningful difference. And so that's what I tried in this one, but you can see the cover crop's not growing very well in there, so I think I overdid it. But I'll just give it more time and try again.
What do you start your Johnson Sue's with?
It's the same sawdust and cow manure, and then I just get leaves from the forest and mix that all in there. And I mix it in with a tank and some clay and some of that EM1.
Yeah. And are you aerating through the top too?
Yeah.
Inside?
Yeah. We move them around a lot and they usually collapse at some point. But I sort of figure once it's heated up that first time, it probably doesn't matter. There's enough wormholes and everything else that I don't worry about it too much. But.
So what you're applying is the soil or the compost that ends up?
Yeah, so this is the one we've been in. And so for example, we'll just take a scoop like that. And what I do is every time we fill up the transplanter, I just put like a volleyball size amount in there, and then I just blast it with a hose through this paint strainer bag until it's running clear, and just kind of work it and work it and work it. And the idea is to have some roots and the soil mixed, you know, so we'll just grab a big chunk like so, and now theoretically I'm washing those organisms off of these roots and getting all of those, the whole breadth of the microbes that are in here into that tank. And then because it's just going straight out, there's not time for that to go anaerobic.
I see.
So I'll do that. We add molasses, we add the EM1 and a soluble kelp powder.
Okay. Yep.
And some purchased inoculant.
So you're getting microbes, micronutrients, and then sugar with the molasses to kind of just feed them?
Yep, so really just trying to feed I mean, we're not getting a lot of micronutrients out of here. I don't think that's what I was trying to do with that one, but I got pretty low expectations of that really working.
Gotcha. Okay.
But we'll see.
Yeah.
It gets, these cook for a full year. Or not cook, but they,
You let them go for it.
we let them go for a full year before we start using them.
Then you get like your full 10 acres out of one pot like this?
You could for sure. So they say this goes out at a rate of 2 pounds to the acre.
Oh, okay.
I don't know, we're doing more than that. I don't know what we're doing. We're just doing what's manageable. But it's going out in the transplanter, so it's going right, you know, it's like soaking each transplant whole as it goes out with that extract.
Water wheel.
Yeah, right through the water wheel transplanter. I bought 10 gallons of EM1, which stands for Effective Microbes 1, which is just a purchased inoculant. And I put 10 gallons of that, 10 gallons of molasses. I forget the recipe exactly, but the rest of it's kind of fungible, I think. I put a bunch of soluble kelp powder in there, some fulvic acid in there, and some of that Redmond sea salt. So that all goes in there. And this is basically like kimchi juice or sauerkraut juice is how I think of this. So it's that sort of inoculant. And these are predominantly beneficial, functional anaerobes. So they are microbes that can go anaerobic or aerobic and perform beneficial roles in either case. So I started with focusing on mineral nutrition, and I just wasn't getting the needle to move. I wasn't getting the results I was hoping for the money and energy that I was putting into it. So then I've started really focusing on, okay, now that I know the nutrients are out there one way or another, so I started focusing on getting the biology there to make those nutrients more available, and soil testing says it's working. This might just look like excessively tilled ground to anyone here, and I would understand why you think that. I would just like to say that this, to me, looks like all the videos I watch of cultivators working in the field. I'm always like, well, yeah, in that ground, anybody could make that work, right? So I am thrilled with this. Slightly embarrassed, but also thrilled. So this is going to be our next planting of fall carrots, and this got a full year of cover crop last year. Last fall, it got a soil primer, which is another advancing eco-agriculture program that they do, and it's basically like fish emulsion, seaweed, molasses and some other complex sugars, and a certain sort of microbial inoculant. And that all got added in here when we planted the winter cover crop last winter. Then it had all winter to do its thing, and the microbes could feed and do whatever, and the stuff grew up. And then this spring, it came up, and it was, you know, that cover crop would have been buckwheat, oats, peas, winter peas, but also winter barley, winter wheat. I don't think I put winter rye in this one, but that was really just because we were out. Stuff that overwintered, vetch. And then this spring when that came up, I mowed that off early, worked it up using this technique that we're going to talk about, this kind of surface composting technique, and then planted a spring cover crop that only got maybe that tall before we worked it in again. So it's a lot of tillage to get to this point where it's ready for carrots, but at each step we're adding microbes, microbe food, and planting cover crops. So it's not staying empty for extended periods of time, except right now ahead of the carrots to hopefully get a weed flush before we plant our last fall carrots. All right, so this I wanted to talk about a little bit. When I first started cover cropping, I was just trying to grow as much biomass as humanly possible, and I got really good at growing rye that was like this tall and thick, and it was great, and I thought I was doing so good. And then I would have to mow it down, which was always interesting, and then I would have to try to incorporate it into the ground, and it was just like, it was like trying to spread straw mulch and then till it in or something. I mean, it felt impossible. So I would disc and disc and disc and disc and chisel and disc and disc. And I was waiting for it to get to anthesis so it would die from mowing and that sort of stuff. I have since given up on that, both for mental health reasons and because I think it was Gary Zimmer. I saw something with Gary Zimmer, and he's like a dairy nutrition guy. And he was talking about feeding cattle. And then he switched and started talking about how earthworms are kind of like cattle on a crop farm he was talking about. But so here we don't have ruminants grazing off our cover crop. What we have is worms and microbes that are digesting it. And so I started thinking about that, and I was like, oh, well, you can't feed a cow even, which does have a rumen and all this stuff. You can't just feed them like bales of hay or straw. You can feed them bales of hay. You can't feed them bales of straw and expect them to be high performing and thriving, especially, you know, taking microbes that haven't had any significant amount of organic matter to chew on and then just like cramming bales of it down their throat. So I started thinking about that and thinking, well, what if we just cut it earlier and just cut it more times? And so that's basically what I started doing, was I would just get in there as soon as it made any sense to go in, and I would cut the rye this high while it still had sort of a digestible carbon to nitrogen ratio. And then what I found was, by adding vetch in there, I would mow off the rye and the vetch would come through, and it would just be this beautiful mix of rye. And now I'm using rye and winter barley and winter wheat and vetch, and then I also do stuff that frost kills in there with it when I sow it. But this all got sown last fall. The oats, peas, buckwheat, all frost killed. This spring, this was just a big stand of rye, it looked like. Went in there, mowed that off. This vetch came through and was big and beautiful, mowed that off, and now this is here and it's ready. I probably would have mowed it a week ago, but I wanted to show you guys. So now we're gonna mow this and do what's called surface composting. And so the next step that I got to, from saying like, okay, I'm gonna try to feed my microbes hay instead of straw, is now I'm using that EM1 and we're spraying that on out of the front of the flail mower there. So you can see the tractor with the flail mower behind, and then it sprays out of the front and just kind of coats all the leaves right before they get chopped. So it's like making sauerkraut, like making kimchi, something like that. You're getting those coated in those microbes, chopping them into small pieces, and then right behind that coming through and disking or rototilling, shallow incorporation, and trying to get a lot of soil stuck to those now wet, chopped up leaves is the idea. And it's one of those things where timing, I think, can really make it work better. But the whole thing is just to really help the biological inoculation really helps set things in a positive direction. So, you know, it's like making wine or anything else, right? It can go off. So what we want to do is, if we get the wrong temperature or the wrong weather pattern or the wrong mix of ingredients or whatever, we want that to go in a positive direction. So that's what the EM1 is about. That goes on there, and it basically just starts that fermentation process. The fermenting, that anaerobic fermenting, so then once you disk that in, you're adding a ton of oxygen, and it's going to actually heat up a bit. I mean, it's not going to get like a compost pile because it's just thin and spread out, but it's heating up with all this microbial activity. But they will gobble up that oxygen faster than it can come through and replace itself. So after that first day or two, now you're relying on those functional anaerobes to do your decomposition. And they are able to, because it's not oxidizing as they're breaking down, they're keeping more of the nitrogen, keeping more of the carbon. So the theory is that with adding that into the mix, you're getting better nutrient retention, and you're also increasing your soil carbon more for two reasons. Probably the most important one is because this is a faster, more thorough tillage than what I would do before. I'm much more comfortable doing an overwintered cover crop that includes rye, barley, wheat, things that are gonna survive the winter, vetch. So that means more of the year, because we're that short season and so much is early spring and late fall beyond when we're gonna be out here working the ground, we can be capturing photosynthesis and pumping those sugars produced in the plant from photosynthesis down into the roots. And that's like the liquid carbon pathway. So just having more growing crops, a diverse stand of growing crops, pumps much more carbon down into the soil. So that's one way that we're increasing organic matter. And then the other is by using fermentation in our decomposition process instead of just aerobic oxidative decomposition. We're taking advantage of that fermentative anaerobic decomposition as well, which holds more of the micronutrients and also the macronutrients like nitrogen and carbon. That kind of fallow field here, and it gets a full season, so winter cover crop through summer cover crop, and some of it gets another winter depending on whether we're going in early or late the following year. But it gets cover crop that whole time. And what we're doing is we give it a so that's all part of this same block. It's just on 2 different timelines. So that one is going to go into a summer frost killed cover crop mix so we can get in there in the spring, and then this one will go back into another overwintering cover crop. But in the middle of the season now, it's bare and empty and worked up for a couple of weeks. I don't want to go more than a couple of weeks because I don't want to really kill off those microbial populations too much, but I do want to totally reset perennial weeds and just not wrestle with them anymore. And so that's kind of the process and the theory behind this part of it.
Tenzin, you'll just keep disking that then?
This over here?
The one that you've got disked down.
That one's ready to plant now, so it's done.
Weeds, though. How are you doing that? You're
Just by disking it up and then leave it for 2 weeks, and then I'll disk it and plant it. So I just disked it, it's ready to plant now. And the, so I was talking about that fall soil primer that we did last fall, and my new strategy, as of like today is that's basically what's in that tank. So I'm doing this fermentative process when we cut the cover crop, and then adding that soil primer in behind as I incorporate with the disc. So we're kind of doing both of those things at the same time. And what we're really trying to do is just get a biological explosion in those top few inches with the soil and chopped up cover crop all mixed together. Just get that as full of biological activity as we can, so that it will break down all the residue, because there's a lot. And if you can walk out in here, it's kind of neat actually, because it's been mowed off a few times, so it looks like just a lot of legumes, but there's a lot of broadleaf stuff in here. There's all this straw residue from the rye and barley and wheat that got in here. So when this all gets incorporated, it's a pretty, full diet for the microbes, I guess is what I'm trying to say. So you've got some old lignous material, you've got some fresh young stuff. This all got frost seeded as well, so you can see like the crimson clover and stuff, that got frost seeded in the spring and it's coming up. These clovers, this might be berseem or yellow clover, I'm not sure. And so the idea is just to have a lot of different life stages of different types of plants happening in here all at the same time. So that we can have as much microbial diversity below ground as possible. And then we ferment it, basically make silage out of it, incorporate it with this kind of soil primer, which has all the molasses and the kelp and all that sort of stuff. And so that all those microbes that are going out have an immediate food source available, but then they also have a lot of food to just explode their population on. A couple of benefits to that. One is you can shorten the time frame that it takes to disc all this material in and then be able to come in and plant carrots. So that's probably been, that didn't look like this, but that was like a 8 to 10 inch tall cover crop in there 2 weeks ago, three weeks ago. So that's, to me, that's really impressive reduction in, I don't know, we call it trash, it's the wrong word, but and so having that hotbed of microbial activity will, once it eats up the easy to digest stuff, there's going to be just so much activity. It'll go down, it'll chase those roots down, it'll digest the roots going down deeper, which helps get rid of these more perennial weeds. And it will also digest weed seed in those top few inches. So you get a much cleaner set for the next cover crop or the next crop. So looking to the future, I would love to be able to do that and then not have to shape raised beds and be able to use that as like a stale seed bedding process and plant carrots or whatever straight into there. But my wife is much smarter than me and she won't let me do it yet. Because the raised beds work.
So are you planting something in here yet? So you're going through this whole process, and then what's going in here?
So what's going in here is that one's gonna get a summer cover crop any day now, especially if rain comes on the horizon, that'll light a fire and I'll get it done. This is going to go through a reset, and then it's gonna get sort of a fall cover crop mix, which isn't a whole lot different except that it includes some overwintering species as well. And
Touch it again until spring?
And then I won't touch it again until spring. This one, depending how fall goes, I either won't touch it again till spring or I'll mow it and just mow it. Well, that's not true. I'll mow it and dust compost over it at some point in time. But and that will be early carrots and this will be later carrots. So that's when I say that my weed control strategy starts 14 months ahead, that's what I mean, is we're really trying to create very biologically active soil, but we're also trying to burn through a lot of different weeds at different times of year. So this is a strange time of year to have a reset on, mostly our weeds are really happy this time of year. So to give them like a midsummer couple of weeks, really, it just changes the dynamic on the weeds. So a lot of the ones that get missed through our normal cropping practices, now we're taking care of them by doing that mid-season.
Now, do you think that in the future, that you'll get to the point where you feel that your cover crops are going to give you enough that you can maybe even stop doing your manure application, your compost application, or you just feel like that's not going to be an option?
I strive to get there. My long-term vision is instead of getting manure-based compost is to use that chopper box and a flail mower and mow off so down at the bottom here used to be a marsh hay, and now it's willow brush and marsh hay and all kinds of stuff, right? But is to basically chop that, compost it, and use that. I think some amount of micronutrients are going to leach out of the system, so we'll have to be replacing those. Some amount of macronutrients, that's what we're selling.
Right.
So the whole idea is that we're selling the healthiest food we possibly can. So if that's there, if that's going out, then something needs to come back. I don't think it needs to be the pound, I don't think you can really measure the pounds of nutrients that left and then need to replace them, because I believe that the system is creating more nutrition. I did a total nutrient digest, so I know that there's way more, when we started here, I thought we were phosphorus deficient. I no longer think that we were ever phosphorus. I think the plants were phosphorus deficient. I don't think the soil was. I think just they didn't have access to it. So I think if we can grow plants that are, if we can grow cover crops that are like supremely healthy, and that's what we're feeding our microbes and our earthworms, then they're healthier and they're thriving. And then when that seed gets planted into soil that's really full of biology and biological activity, the seeds or at least the plants have a way of sensing that, and so they will really invest by pumping their sugars down into the ground. So what I strive to do is, instead of thinking, oh, okay, a crop of broccoli came off of here, what nutrition was in that. We're gonna need to replace that. I would like every bed of broccoli to get lifted and have a better analysis in the soil for growing that broccoli, because the broccoli was so healthy that it was actually giving more than it was taking. Huh? In January it does.
Tenzin, have you seen your organic matter go up in the soil tests?
I have seen it go up. So when we got here, we were at like 2.5 to 3, and now we're at 3.5 to 4.5. I'm simultaneously proud and not of that fact. I'm glad it's going the right direction, but I mean, to be perfectly honest, I've put an awful lot of carbon out here. Like, I carried it out here, so I know that it should be going up. And I think that this strategy, which has been, kind of in development over the years, but really been going on, I would say 3 years, and very specifically only in less than since last fall till now. I'm hopeful that will allow our organic matter levels to go up more readily. Been changing a lot over the 10 or 12 years we've been working on it, but the fastest change has been in the last 12 to 24 months, I would say, where I've really seen a texture difference in the ground. And that's a number of things. One is gobs and gobs of gypsum. Like, every 2 years I put 2,000 pounds of gypsum on. We've got really high magnesium soil, and it's very tight. And when we got here, it was very schmeary. It would stick to the tractor tires all the time. If it rained, you were out of the field for a week. Now, if it rains, we can often get in the next day. So that's been a big difference.
Are you adding gypsum regularly, or just get it to a point and then?
I think I'm done adding 2,000 pounds to the acre.
Okay. Yeah.
Every 2 years. But I plan to probably add 500 pounds to the acre as part of our regular fertilizer. So instead of purchasing, here's something I want to talk about. Instead of purchasing composted poultry manure and putting a couple thousand pounds of that out to the acre, what I'm trying to get more into is gypsum and like plant-based compost, milder sort of stuff, and less of it going out as a fertilizer, and doing most of the fertility through the big bulk compost pile. So that's my main contribution to the, in terms of nutrient application, comes through that fall compost. And that's going into cover crops again, which are going to, because there's so many more roots per square foot and so many different types of plants all growing in that cover crop, that's what's really going to take up those nutrients quickly and hold on to them and keep them bioavailable into the next growing season. Also, one thing that I learned is that especially the heat-treated poultry barn crumbles, if you're putting thousands of pounds of that out per acre, that's almost the same thing as a glyphosate application in terms of residual glyphosate that comes through. So it's allowable under organic standards. That's what most organic farms are using. But the way that glyphosate works is it ties up micronutrients and makes them not available to the plant. So that means that so that might have something to do with why I wasn't seeing those micronutrient levels. Even though I was adding micronutrients, they were just getting bound up because I was also adding a significant amount of glyphosate residue, conceivably. I mean, I never measured on our farm what we were getting. The fertilizer that I get now is tested glyphosate free, and I'm just using less and less of it. And the way they get it glyphosate free is by actually composting it. So some number of bird flus ago, it started getting a lot harder to find actually composted poultry manure, and most of what we find is heat-treated poultry manure pellets basically. And so those have not undergone that composting process and haven't broken that glyphosate down into something else. So that's the way I understand it anyway. It convinced me, and I switched a number of things. And since then I have started, this is the first time we've seen micronutrient levels coming up. That's a sample group of 1, but that's my experience. Flaky, you know, it was just, these tracks would have been just clay and there'd be clumps of like light brown clay all mixed in here that was not homogeneous, it was not loose. And the other thing that I noticed with this is it's very loose, but there is aggregation in there. When I did this, the tractor was not as revved as it normally would have been. For how dry it's been, it wasn't blowing clouds of dust all over the place. And I can run the cultivator through it. So the other stuff with like smears of clay in there and kind of these hard clumps, when you try to cultivate tiny little beets and carrots like that, you know, it doesn't take a very big piece to get flipped over by that cultivator blade and land, and now you got 1, 2, 3, 4 carrots out of commission. So this year cultivation has really gone a lot better and been really fun to do. A lot less getting off the tractor and swearing at stuff, and a lot more just driving and looking back with a smile. I do my earthworm counts in the spring. That's like a good, when you're still sitting on your hands, raring to go activity. But then I think to your point, Song, I look at the ground a lot. So I dig little holes, I'll pull up the roots and see like if the dirt is clinging to the roots, if the roots are stunted below a certain point. And then soil texture is really fascinating to me. So like I said, when we got here, it was very schmeary, hard, flaky when dry, schmeary when wet, and hard to work with, frankly. And in a very clear line, you know, it was like 4 inches of dark brown and then like infinity inches of very light brown with very different characteristics. And now I find that if I go a spade deep, it does get a little lighter toward the tip of that spade, but it's not a clear line, and that dark brown is way deeper than it used to be. So I guess that's how I test.
Hi again, everybody. I already introduced myself a little bit, but just a reminder, my name is Melissa Ohlrich. I'm a regional crops and soils educator with UW Extension, covering Marathon and Clark counties. We're going to talk to you today about soil health, and we're going to show you some fun demos to go along with that. So for starters, I just want to kind of do a brief introduction of soil. So you all work with soil a lot, think about it a lot. Broad picture, when you think about soil function, what do you think about? What do you think of as the purpose of soil? Does anybody want to shout anything out?
Hold your plants up.
Yes. Yes. Anything else?
Hold your nutrients.
Yes. That is another good one. Yeah, so you guys hit on 2 of the big ones. We might think about like nutrients. It is the place where our plants can get nutrients. Maybe you think about water. It's the space that holds on to water for our plants to use. It's a home. There are so many living things that call soil a home, right? And it also provides physical stability. It is the medium that our plants exist in. It is what's holding them up every day. So these processes, all big picture, are very important for soil health. And when they are not maybe working the best that they could, this can really impact negatively things like our crop yield and our crop quality. So just a little intro to get us thinking about what is soil? What does it do? I'm gonna pass it over to Emilee. Okay, so let's talk a little bit about soil structure. What gives soil that really important structure that we depend on, that it allows us to have those really important functions. So what gives soil its structure is a soil aggregate. It's like a clump or a cluster of different parts of the soil. So if you have your mineral parts, like your sand, silt, and your clay, and as we were mentioning, your context matters because different soils will have different amounts of sand, silt, or clay. And then also and then combined with that is organic matter. And that was anything that was once living, like your cover crops, if you work that into the soil, if you add something like compost or manure to your soil. And those soil minerals and the organic matter get bound together basically by, think of like a glue, and that's released by your plant roots, like Tenzin was mentioning about. It's called a root exudate, and also those important microbes that live in our soil, they also help release that kind of gluey substance that holds our soil into these important like groups. And then how these groups or clusters stack up, that's what really gives the soil its structure. We want them to be different sizes, so as they stack up, it's not like a solid, think of like a solid brick, but rather we have pore space. Yes, thank you. We have pore space, kind of like a sponge. So think of like your cleaning sponge. It can still hold a lot of water, but there's still room for things to move through. Where if you stacked up something like bricks, there's not going to be space for like your roots to move through your soil. So you're going to maybe have a smaller root system, not as healthy of a plant. Thanks, Dan.
Yeah. So I took this down at that little natural area down there. We kind of want our soils to look kind of like this little granular. I think Tenzin kind of pointed that out down there. So it's more like cottage cheese. I always say chocolate cake, you know, that flaky, so something that's very crumbly. That's kind of where we're aiming for our soils. Now this, let's see which one. Oops, oh, I need that. So this was actually, let's see, this one, I think it was actually put here. Now that I was kind of wondering what was going on, because it was like, this is not what I was expecting. So if you look at this, you can almost see it does look like plates or like bricks, like Emilee was talking about, kind of stacked up on top of each other. And that's what compaction looks like. So we don't necessarily want to see these plates in our soil. Why don't we want to see plates on our soil, or let our soil look like plates?
Less space for water, air.
Exactly. So if we had a bunch of plates piled up on this table, and I took my pitcher of water, dumped it over those plates, where does the water go? It kind of goes off to the sides, not down. Where this, I guess to keep on my analogy, maybe this is more like marbles. So if we had a whole thing of marbles, and we poured my water down there, where does the water go? It goes down. So I guess so, marbles and plates. Marbles are good, plates not so good. Okay? All right.
And this little sheet here, this is what you can, oh, thanks. This is what you can kind of look for, just some simple visual observations you can make really quickly in your field. I know farmers are really busy, but you can look at exactly what Dan just mentioned to see, do you actually have the aggregates in your soil? Is your soil holding well? And if you have strong aggregates that is correlated with healthier soil, you'll be able to better withstand any like impacts, like tractors driving over it, people walking on it, or even just like the rain constantly hitting the top of your soil. Dan is also going to do a little bit of it's a simple test, but you can take it just a step further to see really how strong those aggregates are.
So yeah, a really easy test. So these are just sink strainers. You could buy them at, I don't know, Dollar General, wherever. And you take a little bit of clod of soil. So this little piece here, this actually came out of this tilled area right there. And then this little piece here actually came down in that little nature area. So as you're looking at these, which ones do you think would hold together the best? Tenzin knows. I think our soil scientist over there knows. Okay, so what we do is we just take a little bit of water, we let them soak, and actually I need a little more water in there. Why? Maybe I got too much soil. Oh, maybe not. Yeah, let's fill this up a little bit more. And we just let those soak a little bit. All right. So if you want to come closer, okay, so the stuff that came from the natural, yeah, you'll see some, but look how much the tilled is actually, you know, there's like large flakes. So if I tap that, there's more large flakes. So we want that nice soil that kind of holds together a lot of roots and not necessarily, you know, stuff that's been tilled a lot. Now I know vegetable production is different. You do need tillage. Tillage is a tool. So just like Tenzin's doing, use it judicially, use it when you have to, but then in those off seasons, or even like in between your rows or whatever, have some of those living roots established, and that will help with your soil structure and improve things. Another thing you can do, I think these are wet enough. Hopefully this will work this time. After these have been so saturated, oh yeah, that's gonna work. I could do that and put this, whoops, tap that. We can almost tip these. Well, that one's not wet enough yet. But you could tip it, and you know your poor soils will actually drip down the plate. This one's held up. So, so Emily mentioned a lot about microorganisms. Tenzin mentioned a lot about microorganisms and carbon. The plants actually pay the microorganisms a fee in the source of carbon. So the plant produces all this carbon. How much of that do you think it sends down its plant into its roots to pay those microorganisms to do their job? Any guesses? It's like 80% of the carbon that the plant produces gets pushed down the plant into the roots, pays those microorganisms, and in turn those microorganisms, like fungi, there's a mycorrhizal fungi that loves to explore, connects to the roots, it loves to explore, grab that phosphorus, grab that water, bring that back to the plant. The same thing with like all those other microorganisms in what we call the rhizosphere, around that area around the roots. It actually does a lot of that converting of nutrients, bringing those nutrients back into the plant for them to use. It's pretty cool. Yeah. So that's why it's so important when we're talking about carbon and microorganisms and keeping living roots and keeping those organisms happy and fed all year long.